Welcome to today's lesson. So today's lesson is a Form 2 agriculture lesson. So the topic is about phosphatic fertilizers, and you are with me, Andrew Cobby. So normally most soils they contain a large amount of phosphorus, though the phosphorus which is found in the soil um, it is available in the form which cannot be absorbed by plants. But most of the soil they have got phosphorus. But the phosphorus available in the soil cannot be absorbed by the plants. So phosphorus form insoluble compounds with other minerals. So they form insoluble compounds with other minerals. That's why that phosphorus cannot be absorbed by the plants. So let's look at the properties of phosphatic fertilizers. So the following are the properties of phosphatic fertilizers. The first one is they are not readily leached. We talked of leaching. Leaching is the going down or washing down of nutrients, the layers where the plants cannot leach. So these phosphatic fertilizers they are not readily leached. Then they are slightly soluble in water. That's another property. They are slightly soluble in water, unlike other kind of fertilizers. So in acidic soils, much of the fertilizers is converted into insoluble compounds, and that's become fixed. So when you've got acidic soils, if you apply phosphatic fertilizers, that phosphatic fertilizer is converted into insoluble compounds. So that insoluble compound cannot be absorbed by the plants. Thus, they become fixed. So due to this fixation, phosphate fertilizers must be placed in root range of growing plants. So due to fixation, they have to be close to the roots of the growing plants. For example, you can use drilling or mixing with the soil in the planting hole. In the same planting hole, you mix with the soil. So phosphatic fertilizers have a long residual effect. What it means is after you apply, take a lot of time to release nutrients. It releases nutrients for a long period of time. Okay, so in some cases it can take up to 4 years still releasing the nutrients. So that's what it means by having a long residual effect. So unlike nitrogenous and potassic fertilizers, phosphatic fertilizers have a slight scorching effect. What it means is they don't scorch the crop as compared to nitrogenous as well as potassic fertilizers, because nitrogenous and potassic fertilizers they have got that uh, high scorching effect. So let's now look at examples of phosphatic fertilizers. So the first example is single superphosphate. So this single superphosphate it contains 18 to 21% of uh, phosphate oxide. It also contains sulfur, which distinguishes it from double or triple supersulfate. So double or triple supersulfate, they have very little or no sulfur at all. The other property of single supersulfate is that it is granular, creamy white, and much whiter than the double and the triple superphosphate due to its high lime content. So because of high lime content, it is granular, creamy white, and much whiter as compared to double and triple superphosphate. When applied to the soil, most of the phosphate oxide diffuses out in calcium phosphate form. So when it has been applied to the soil, most of its phosphate oxide it diffuses in the form of calcium phosphate. It also it can remain in undissolved state for several months. So it can stay in undissolved state for several months. And this phosphatic fertilizer is neutral fertilizer. What it means, it is not acid and it is not base, so it's just neutral. So this is just a picture of single super phosphate fertilizer. So just for you to appreciate how single super phosphate fertilizer looks like. So let's look at double and triple superphosphate. This is example number 2. So double and triple superphosphate, it is usually granular, gray in appearance. It contains about 40 to 49% of phosphate oxide. Another example is soda phosphate, which contains up to 20% of phosphate oxide and may contain other elements. So apart from phosphate oxide, it may contain other elements like calcium oxide, 30% of iron oxide, and small amount of zinc. You talk of magnesium, you talk of boron. It is good for soil lacking trace elements, since if you can see here, we've got small elements or trace elements like of magnesium, zinc. So it is very good for the soils which are lacking trace elements, because this soda phosphate, it is able to provide the trace elements to the soil. Then the other one, I've got basic slag. That's another example, basic slag. So basic slag, normally it contains 15 to 16% of phosphate oxide and 40 to 50% lime. It is therefore suitable for heavy acidic soil such as clay. Since it has got lime, therefore it is suitable for acidic soils. You know, lime, it helps to neutralize acid. So a basic slag contains small trace elements. So it also contains some small trace elements. Talk of magnesium, you talk of iron, sulfur. So it is also it is highly basic and should not be mixed with other another fertilizer. So it is also gray and powdery. So let's now look at potassic fertilizer. We have looked at phosphatic fertilizer. Now let's look at potassic fertilizer. So potassic fertilizer have moderate scorching effect and are fairly soluble. So they have got moderate, it means they are on the middle. Okay, they are on the middle as compared to nitrogenous and phosphatic fertilizer. So these are moderate, they have got moderate scorching effect and they are fairly soluble. So when we talk of fairly soluble, it means they are more soluble than phosphatic fertilizers, but less soluble than nitrogenous fertilizers. What it means is nitrogenous fertilizers are more soluble. Then what follows now is potassic fertilizers. Then the last one is phosphatic fertilizers. Then sources of potassium include crude salts, seaweeds. All these are sources of potassium. Talk of wood ashes and potassium containing rocks. So there are some rocks they contain potassium. So they are all sources of potassium. So it can also be produced as a byproduct in the manufacture of cement. So when they are manufacturing cement, potassium can be produced as a byproduct. So it should only be applied where the soil tests show potassium deficiency. So after the soil has been tested and there is lack of potassium, that's where you can apply potassic fertilizers. Let's look at examples of potassic fertilizers. So the first example is muriate of potash. So this one is potassic fertilizer. So muriate of potash is also known as potassium chloride. So it is a crystalline white red fertilizer containing up to 48 to 62% of potassium oxide. It contains impurities of calcium, magnesium, sulfur, as well as some trace elements. So it is hydroscopic and water soluble. So on top of hydroscopic, it has got a tendency of absorbing the moisture. So that's why it's saying it is hydroscopic and water soluble. And this muriate of potash has no residual effect on the soil. It means it does not stay for a long period of time supplying nutrients to the soil. Another example is the potassium sulfate or sulfate of potash. So this one is this crystalline yellow water soluble fertilizer containing about 42 to 52% of potassium oxide. It is manufactured by combining muriate of potash with sulfuric acid. So there's combination of muriate of potash and sulfuric acid forming potassium sulfate. It also contains some trace elements. So unlike muriate of potash, potassium sulfate is not widely used as fertilizer. So unlike muriate of potash, this kind of fertilizer, it is not widely used as fertilizer. So this is just a picture of potassium sulfate so that you can appreciate. So it's just a picture of potassium sulfate. So another example, or the last example, is wood ashes. So wood ashes is also an example of potassic fertilizers. So they vary in the amount of potassium they contain. So hardwood ashes are generally richer in potassium than soft wood ashes. So you know, some wood are hard, others are soft. So the hardwood generally they have got a higher potassium as compared to softwood. The wood that has been burnt at high temperature produces ashes much lower in potassium than that burnt at lower temperature. So if you burn the wood at very high temperature, it means the potassium produced, the ash will have much lower potassium than the wood that had been burnt at lower temperature. So thank you for watching this video. If I've got any question, that's our WhatsApp number, and you can also visit our website, our email there. Thank you so much. See you in the next video.